So this is part 1 of the Chapter 1 practice test. It covers sections 1.1 through 1.4. And always, when I create a practice test, it's designed to be the best study guide for the test that you're going to get in class, meaning that I should never ever put something on an in-class test that isn't just like the practice test. So if you can do all the problems on this practice test, you should be completely ready to do the test. Of course, there's going to be 2 parts because the chapter has 7 sections as opposed to 4. And right now, you should just be ready to focus on part 1. The best thing you could do is before watching the video, try to do the practice test, and then watch the video kind of with your answers in hand, just to make sure you're kind of on the thinking the same I am. So problems 1 and 2 give me sets that contain only natural numbers, and they want me to write word descriptions. Somewheres in my description, my word description, which is maybe a sentence to describe the elements of the set, I should probably use the word natural numbers for both 8 for problems 1 and 2, because the numbers are natural numbers. If I don't say natural numbers, that might allow decimals or negative numbers that I don't want. So for this problem 1, I might say set A, or A is, how about A is the set of natural numbers. And now that only excludes, the negative numbers, the decimals, and the fractions. It doesn't describe these numbers. And I would say the numbers start at 8 and get bigger. And probably the nicest way to say that in words, it might be using the words greater than or equal to 8. Because I need the equal to include the 8. And then the greater than part gives me the 9, 10, 11, and 12, and so forth. There are certainly other correct answers to problem 1. When I did the video over section 1.1, I might have written 2 or 3 answers each time I was asked to do a word description. On the practice test here, I'm only going to do 1 example. And if you have a different answer than mine, you're more than willing, you can just show me the answer and I could tell you whether I'd call that correct or not. When I do question 2, I might start off saying B is the set of natural numbers again, because the numbers 8, 9, 10, and 11 are natural numbers. And then, because there's a highest and a lowest number, I usually use the words between in my description. So instead of having a greater than or equal to, I'm going to say between. And the way I like to do the between problems is I like to state what the first and the last number are. And, of course, we have to put one more word to make sure that we're counting the 8 and the 11 and not excluding the 8 and 11, and that's the word inclusive. Generally, when I'm asked to do a word description, when we have a set that has a highest and lowest number, I use exactly this sort of word description. Again, if you have a different answer, that doesn't mean it's not correct. Just show it to me if you're not sure whether it's correct or not. 3 and 4 want me to do set builder notation, and set builder notation is my least favorite. The set builder notation is going to start off with the set brackets, and inside the set brackets you have a vertical line. I read this as A equals a set of all something with the property that. Usually before this vertical line, unless I have a reason to use a different letter, I use the letter X. And then after the vertical line, I write symbols to describe the elements of the sets. Just like in problems 1 and 2, these are natural numbers. And the nice way to say that the set only contains natural numbers is to use X as an element of n. You could, right here, you could say X is a natural number. So you'd have a little bit of flexibility. I'm writing the slickest answer I can think of. If where I wrote that symbol X is an element of n, you wrote the words X is a natural number, that would be completely fine. I'm going to follow it by a comma, but if you wanted to use the word and instead of that comma, that would be fine. And then After the comma, I need to describe the numbers, and those are the numbers greater than or equal to 8 again. I don't think there's probably a nicer way to describe the numbers other than their natural numbers and they're greater than or equal to 8. This part after the comma or after the and, I wouldn't probably write any differently. So an alternate choice might be able to do an answer like this. A equals the set of all x with the property that x is a natural number and x is greater than or equal to 8. That's actually the easier of the two. When we have a set like number 4 and we need to do set builder notation where we have a lowest and a highest number, we usually, when we get to the right hand side, have to put an x between those numbers with less than signs. But let me get started with this. So for set builder notation, I'm going to write the name of the set followed by the squiggly set brackets, and then I'm going to put an x in a vertical line. So this reads P equals the set of all x with the property that, and I need two things. I need x to be a natural number. Two ways I can do that. You can use the symbols for x as a natural number, or you could use the words, whichever you prefer. I like the symbols because it's easier to write, but what I'm about to write now would be one of these two things would be correct. After this, I could write a comma or an and. I like the comma. And then the hard part is to show between 8 and 11 exclusive. Usually in these set builder notations where we have a range of numbers, we have a highest and a lowest number, we put an x between the highest and the lowest number, and the only kinds of symbols that we put between the numbers and the x's is either less than or less than or equal to. Less than would definitely fit for the word when the word in the problem after the numbers is exclusive. Less than or equal to would be the word that the symbol that I would choose if this word was inclusive as opposed to exclusive. Because it's exclusive, I'm just going to put less than signs. That's the answer I would come up with number 4. There's definitely other correct answers. But not one that I would write. The next 3 problems want us to do the third kind of writing for sets and write the set in roster form, which is my favorite form. I just have to list the numbers in the set. That's what I'm asked to do for problems 5, 6, and 7. So I'm given some either word description or set builder notation to describe a set, and I'm asked just to list the elements in roster form. So for question 5, I'm going to write the set name, which is A, followed by an equal sign, and then I'm going to put some set braces, and inside the set braces I'm going to write all the numbers that are in the set. And the numbers in this set A are natural numbers, so I'm not going to have any decimals or fractions or negative numbers, and they have to be greater than 4. So I'm only going to put numbers that are essentially positives without decimals or fractions, and I'm going to start with the first natural number greater than 4 because I'm not allowed to include 4 because it doesn't say or equal to 4. So I'm going to start at 5 and get bigger. Since there's no end number, this pattern needs to go on forever. At some point, I stop writing numbers and I write ... to indicate the pattern goes on forever. 3 is the minimum number that you could show to establish a pattern. So probably on my key, if this was a test question, my answer would look like that. A equals the set 5, 6, 7, and so forth. But what I have above is equally correct. For question 6, again, the name of the set is A. It only contains natural numbers, so when I go to list the elements in roster form, I won't have any fractions or decimals. I see between 7 and 11, and then the keyword inclusive, which means in my listing, I'm going to do all the natural numbers between 7 and 11, and I'm going to include the 7, and I'm going to include the 11. If it said exclusive, my answer wouldn't have the 7 or the 11 in it. So I'm just going to write A equals, I'm going to write 7, 8, 9, 10, and 11, which are all the natural numbers between 7 and 11, if I include the 7 and the 11. If the problem said exclusive, then that answer that I gave is an answer for an inclusive. I can't even spell that this morning. If it said exclusive, my answer would have been A equals just 8, 9, and 10, because exclusive would include the numbers that were mentioned. On the test, I would feel comfortable doing either. I scratched out B because it wasn't written quite right, and I just wrote it how it should be written, and I should fix it on my computer quickly here. So B is a set of all x such with the property that x is a natural number and x is between 3 and 7, includes the 3 because of the or equal to, doesn't include the 7 because of no or equal to there. So I know that for set B, I'm only going to put natural numbers, and I'm only going to put the natural numbers between 3 and 7, and an or equal to means to include that number. A not or equal to with the inequality means to exclude that number. So I'm going to put all the natural numbers between 3 and 7. I'm going to include the 3, but I'm not going to include the 7 in my answer. So instead of writing 3, 4, 5, 6, and 7, I'm only writing 3, 4, 5, and 6 because I'm excluding the 7 because it doesn't have an or equal to with its inequality. 8, 9, and 10 want me to find the cardinal number of a set, and the cardinal number is just the number of elements in a set. So in order to answer questions 8, 9, and 10, I need to know the elements of the set. So first, for problem 8, I'm going to find the elements of the set, and then my answer isn't going to be what the set that I constructed. It's going to be the number of elements in that set. So in problem 8, B is a set of natural numbers between 5 and 7, including the 5 and 7. So B is the set that contains the numbers 5, 6, and 7. That's writing the set in roster form, although I didn't do anything wrong. I didn't answer the question. The question is, was the cardinal number of the set? And when I go to write my answer, a slick way to write my answer would be the small lowercase n followed by a parentheses with the set name and then an equal sign, and then the number of elements in that set would go after the equal sign. There's 3 elements in that set, and that would be fine. Another way to write the answer, you can say the cardinal number of set B is 3. If you wanted to be super lazy, you can just write the number 3. So all of these would be okay. All what they have in common is they tell me the number of elements in the set, which is 3. Just as long as you get the 3 right and your answer isn't the specific set itself, will be fine. For question 9, I need to create the set that's described here. Set A is a set of natural numbers less than but not equal to 5. Natural numbers start at 1. So the numbers in set A here are any natural number that's less than 5 but not equal to 5. This is what set A is. It's a set that contains the numbers 1, 2, 3, and 4. All those are the only natural numbers that are less than 5 and not equal to 5. For my answer, probably the laziest answer would be just to write the number 4. There's 4 elements in the set. If I want to do something a little bit nicer, I can do the lowercase n with an A in a parentheses and say the number of elements in set A is 4. And if I cared to write a sentence, I could write a sentence like this. I could say the cardinal number of set A is 4. Problem 10 says find the number of elements in set C, or find the cardinal number of set C, where C is the set that has the letters W, X, Y, and Z. The simplest answer for this, I could count that set up that has 4 elements, would be that. Another correct answer would say the cardinal number of this set C is 4. And the last correct answer, I could say the number of elements or the cardinal number, which is the same thing as the number of elements of set C, is 4. All of these are equally correct answer to problem 10. 11 through 13 want to ask me if sets are equal or equivalent or neither. Equal means they have exactly the same elements. When I look at the sets in problem 11, both sets have the numbers 1, 2, 3, and 4. So one of the things in my answer for problem 11 is I need to say that these two sets are equal. I'm supposed to determine whether the sets are equal. And to be equal, you have to have exactly the same elements. Both sets have a 4. Both sets have a 3. Both sets have a 2. And both sets have a 1. And they have exactly the same elements. There's no extra element in one set as opposed to the other. So those are equal sets. To be equivalent, you just have to have the same number of elements. And in question 11, set A has 4 elements, set B has 4 elements. When two sets have the same number of elements, they're equivalent. So for problem 11, the sets A and B are both equal and equivalent. That's the whole answer for 11. For problem 12, the sets aren't equal because they don't have the same elements. A, B, and C aren't exactly the same as 1, 5, and 9, so they're not equal. But both sets have 3 elements. They have the same number of elements, so these sets are only equivalent, but they're not equal. The answer to problem 12, it just needs to be the word equivalent. You don't need to have the only there, but I just kind of wrote it. And then for 13, they're not equal because B has a 2 in it, and there's no 2 in A, so they can't be equal, because to be equal, you have to have exactly the same elements. B can't have an element that A doesn't have for it to be equal, so they're not equal. And they're not equivalent because A has 2 elements and B has 3 elements, so they're not equal. They don't have exactly the same elements. They're not equivalent. They don't have the same number of elements. The answer to this must be they're neither equivalent nor equal. So my answer to 13 is going to be neither. Might be a little hiccup in the video because I'm redoing a few problems. So for 14 through 16, we're asked to find out if A is a subset of B and not if A is a proper subset of B. And in order for a set A to be a subset of B, there's just 2 rules to check. The first rule is A needs to be a set, and the second rule is every element of A also has to be an element of B. So my answer is either going to be true or false. If it satisfies both rules, I'll write true for my answer. If it breaks one of the rules, I'm going to write false, and I'm going to write the reason why it's false. So for question 14, I'm given the set A and a set B listed in roster form. I look at A, and it is a set because of the set braces. So rule 1 is satisfied, and I'll move on to rule 2 to see if A is a subset of B. The next rule is every element of A also has to be an element of B. A has 2 elements. It has the element A and the element B. Both of those elements appear in set B, so rule 2 is satisfied. Because both rules are satisfied, I'm going to write true for my answer. Feels to me like I might have used yes or no. I'd live with if you said yes, A is a subset of B for an answer, but since it says answer true or false, if both the rules are satisfied, I'll write true. If one or both of the rules is violated, I'll write false. For problem 15, same question. Is A a subset of B given A is the numbers 1 and 2 and B is the set containing 1, 2, and 3? So when I go to check my rules, the first rule I need to check to see for A being a subset of B is A needs to be a set. And this is the rule that's going to be violated because A is not in set braces, so it's not a set. For my answer, I'm going to write false because A is not a set. I'm going to write false because it violates the first rule. And you could write no instead of false. And the reason I'm going to say is A is not a set. 16 is the last one in this grouping. Asks the same question, is A a subset of B given A is the set containing the numbers 2, 4, and 6 and B is the set containing the numbers 1, 2, and 3. To check to see that A is a subset of B, I have to first see that A is a set. Because it's in set braces, it's a set listed in roster form, so it's a set. Second rule is where I'm going to break down here. For the second rule to be satisfied, every element in A would also need to be an element of B. But A has two elements, namely the numbers 4 and 6, that are elements in set A that aren't elements in set B. So for an answer, I'm going to write false, but you certainly could write no, just in case I did that earlier in this chapter. And I'm going to say that A has elements that B doesn't have, or A has a 4 and a 6 that are not in B. Something like that. I guess you could just say rule 2 is violated, and I'd live with that just fine. The next two problems are kind of monstrous because they want me to check all of these possible relations between set A's and set B. So for 17 and 18, we're supposed to determine if, for the sets A and B that are given, if A is equal to B, if A is a subset of B, if B is a subset of A, if A is a proper subset of B, or is B a proper subset of A, and if it's none of these, then we'll write none of these. So for 17, we're given two sets, and I'm going to check 1, 2, 3, 4, all 5 of these to see which, if any, of these hold true. The first thing I need to check is to see if A is equal to B, and to see if A is equal to B, they just need to have exactly the same elements. I look at the elements in A. A contains the numbers 5 and 7. B contains the numbers 7 and 5, which is the same as the numbers 5 and 7, because the order that you write the elements in is not the deal breaker. As long as you have the same elements, it's enough to be equal. So these two sets are equal because they have exactly the same elements. So part of my answer to number 17 is that A is equal to B. The next symbol I'm going to check to see if A is a subset of B, which we've been doing. And there's two rules to check. So when I check to see if A is a subset of B, the two rules I need to check is first, A needs to be a set. Because A is written in set braces, A is most definitely a set. The second rule I need to check is to make sure that every element that's in set A is also an element of set B. And it is the case that this holds, because 5 is an element of A. For A to be a subset of B, 5 would also have to be in B. 7's an element of A, and 7's also an element of B. So every element in set A is also an element in set B. So this is satisfied. So A is also a subset of B. There isn't that third rule that would make this answer no. We'll get to that in a little bit. Next thing I'm going to check to see is if B is a subset of A. For B to be a subset of A, B needs to be a set. I look at set B, it's in set braces, so B is a set. The second criteria for B to be a subset of A is that every element in set B is also an element of set A. And it's the same deal here. B has two elements, 7 and 5, and each of the elements of B is also an element in set A. So this also, step 2, or criteria 2, also holds, and another part of my answer is going to be B is a subset of A. I'll move on to the proper subsets, and this is where I'm going to start getting violation. So to check to see if A is a proper subset of B, where A is a set containing the numbers 5 and 7, and B is a set containing the numbers 7 and 5, I have 3 criteria that need to be satisfied for A to be a proper subset of B. I've already checked the first 2 criteria when I was trying to see if A was a subset of B. It's this third one that's going to violate here. To be a proper subset, the 2 sets can't be equal, and these sets are equal. So I'm not going to include this symbol in my answer, because this symbol, there's 3 rules that need to be satisfied, or 3 criteria. A has to be a set. It's a set because of the set braces. Every element of A is an element of B. A has the elements 5 and 7. They're also in B. The third rule breaks down because A can't be equal to B. I won't include that symbol in my answer. The last thing I want to check to see is if B is a proper subset of A. And to see if B is a proper subset of A, there's 3 criteria that need to be satisfied. And the first 2 we've already checked. B is a set because of the set braces. Every element in set B is also an element of set A because there's 2 elements in B, 7 and 5. They're also in A. But To be a proper subset, the sets aren't allowed to be equal. These sets are equal, so the third rule or the third criteria is being violated. So I shouldn't include B as a proper subset of A in my answer to problem 17 because it doesn't satisfy as the third rule. So the only symbols that satisfied everything they needed to satisfy were A is equal to B, which only had one criteria, that they have exactly the same elements, and A is a subset of B and B is a subset of A, which has the two criteria. Problem 18 asks me to check the same 6 or same 5 relations between A and B. But it gives me A in set builder notation, in set builder notation. Let me rewrite A in roster form. It says A is a set of natural numbers between 1 and 5, not including 1 and 5 because there isn't or equal to on either one of these inequalities. So A is going to be the set containing the numbers 2, 3, and 4. It's natural numbers between 1 and 5, not including the 5 because there isn't an or equal to on that inequality, not including the 1 because there isn't an or equal to on that inequality. So A is just the test sets 2, 3, and 4. The first item I'm going to check to see if A is equal to B. For the sets to be equal, they have to have exactly the same elements. B has the number 5 that A doesn't have, so these sets aren't equal. Next, I'm going to see if A is a subset of B. For A to be a subset of B, it needs to be a set. Well, it was a set initially written in set builder notation. I rewrote it in roster form, but A is most definitely a set. The second thing I need to check to see is every element in A also an element of B. A has the elements 2, 3, and 4. B also has 2, 3, and 4, and that's enough for this rule to be satisfied. Just as long as the 3 elements of A are also in B, that rule is satisfied. So this is satisfied, and part of my answer to question 18 is going to be A is a subset of B. I'm going to move on to see if B is a subset of A. For B to be a subset of A, B needs to be a set, which is most definitely is a set because it's written in set builder notation. The second criteria for B to be a subset of A is that every element in B also needs to be an element of A. This is the one that's going to break down. For B to be a subset of A, every element in set B, 2, 3, 4, and 5, also would have to be an element of set A. And the problem here is that there's an element of set B that isn't in set A. There's a 5 in set B that's not in set A, so that's violated, and I'm not going to include B as a subset of A in my answer because it's not a subset because the second rule is broken down. Now I'm going to see if A is a proper subset of B. For A to be a proper subset of B, I have 3 criteria that need to be satisfied. First, A needs to be a set. It's given as a set in set builder notation, so it was a set. Second rule that needs to be satisfied to be a proper subset, every element of A needs to be an element of B. The elements of A are 2, 3, and 4. They're also in B, so I satisfy the second rule. The third rule to be a proper subset is the sets can't be equal, and these sets aren't equal because B has a number in it that A doesn't, so the third rule is satisfied, and I'm going to include that symbol in my answer because I've satisfied all 3 rules. Moving on to the last test to see if B is a proper subset of A, where B is a set containing 2, 3, 4, and 5, and A is a set containing the numbers 2, 3, and 4. So let's see if the rules are satisfied for B to be a proper subset of A. First, B needs to be a set. B is a set because it's in set builder notation. Second of the 3 rules is every element in B needs to be an element in A, and this breaks down because B has the number 5 in it that A doesn't have. So I violate the second rule. B is automatically not a proper subset of A. I don't need to go on and check the third rule. I'm not going to include that symbol in my answer. I've checked all the symbols I need to check, and the only ones that came out true was that A is a subset of B and A is a proper subset of B. So my answer to question 18 is going to be just that. Alright, there's probably going to be a hiccup in the video again because I'm going to insert these back in, and 19 is something that I was happy with how I did it. So I'll stop here for a minute. Now the part that I like a lot better. 19 gives me a universal set, a set B, and wants me to find B complement. To find B complement, I just go inside the universal set, scratch out the elements of B. What I haven't scratched out is what's in B complement. B complement is going to be the set that contains the letters A and D. 20 wants me to find A, set A intersection B complement. Well, set A is the set that contains A and B. I'm going to leave this intersection problem symbol, and then after the intersection symbol, I'm going to write what B complement is, which is the set that contains A and D. The intersection of two sets is what the sets have in common. Those sets both and only have the letter A in common. My answer to problem 20 is going to be the set that contains the letter A. For 21, I want to union the A set with the B complement set. To do this, I'm going to write down in place of the A set, the set containing the letters A and B. Then I'm going to write my union symbol. And then in place of the B complement set, I'm going to write the set containing A and D. When I union two sets, I take all the elements in the first set and all the elements in the second set. I write them together in a big set, and then I look to see if there's any duplication, because every element only needs to be listed once. I have two A's listed. I only need to have one A listed in my final answer. My final answer as to what the set A union B complement is going to be the set containing the letters A, B, and D. One last page of problems, just two more problems to do. More unions and complements and intersection problems. For problem 22, I need to do the parentheses first. And the parentheses want me to do T union V. Let me just kind of do it off to the side here. To do T union V, I take the entire T set, which is 1, 2, and 3. I union that with the V set, which is 3, 4, and 5. When I union two sets, I take all the elements in the first set and then all the elements in the second set, and I write them in a big set. And then any number or element that's listed twice, I only write it once. So T union V, the parentheses part of this, is going to be the set containing the numbers 1, 2, 3, 4, and 5. So for the problem that I'm asked to do, I'm asked to find S intersection T union V. I can drop the parentheses and change the T union V to the set containing the numbers 1, 2, 3, 4, and 5. Now I'm going to take the S symbol and change it to the set containing the numbers 1, 3, and 5. I'm going to leave the intersection symbol, and I'm going to leave the 1, 2, 3, 4, and 5 in place of the S union T, and now I'm going to find the intersection. When you're intersecting two sets, you're finding what the sets have in common. My answer to problem 22 is what I get when I intersect those two sets that I've just kind of hinted at, what I'm going to get for an answer. Intersections are what sets have in common. Those sets have the numbers 3 and 5 in common. For problem 23, off to the side, the first thing I need to do is V complement intersection T. I need to know what V complement is. To find V complement, I'm going to go to the set of the universal set, and I'm going to scratch out the elements of V, which are 3, 4, and 5. When I scratch those out, what I haven't highlighted are the elements of V complement, which are 1, 2, and 6. So to figure out what's inside my parentheses, I need to take my V complement set, which is a set that contains the numbers 1, 2, and 6, and intersect with that T set, which is a set that contains 1, 2, and 3. And when you intersect two sets, you write what they have in common, and those two sets have the numbers 1 and 2 in common. So the parentheses here I'm going to change to the numbers 1 and 2. I can rewrite this problem as S union, drop the parentheses, drop the letters, and change it to the set containing the numbers 1 and 2. Now I'm going to change the S to 1, 3, and 5. I'm going to leave the union symbol between the sets. And now I'm going to union these two sets. To union two sets, I take every element in the first set and every element in the second set, I join them in a big set. If any element's duplicated, I only need to write it once. The answer for my problem 23 is going to have the numbers 1, 3, 5, and 2. I like writing my numbers or letters alphabetically, my numbers in ascending order. So my answer, I would write 1, 2, 3, and 5 for the set that represents S union the quantity V complement intersection T. All right, so that's everything on the first part of our practice test. So get these down really well before you move on to the second part, which covers sections 1, 4, 1, 5, 1, 5, 1, 6, and 1, 7.